Find the distance between two planes. The planes here are parallel. Their normal vectors are 1, 2, -1, and 1, 2, -1, and those two vectors are parallel. In fact, they're identical, but all we need are parallel normal vectors, and then we would have parallel planes, which then have a positive distance between them. If the planes were not parallel, they would intersect, and the distance between them would be 0. So the distance between these two planes is calculated as follows. We'll take plane 1 and put it here, and we'll erect a normal vector, which we'll call n. We'll put that here at some point q1 in plane 1, and then we'll pick some point q2 in plane 2, and we'll make the vector from q1 to q2. We'll call that v, goes from q1 to q2. And then we'll project this vector v onto the normal vector, and the distance will be the magnitude of that projection. So the distance is equal to the magnitude of the projection of v onto n, and that's the magnitude of the vector. The projection of v onto n is a multiple of n, and that multiple is v dot n over n dot n. Okay, so now for the details. Let's pick a point q1 in plane 1. We'll pick q1 to be a nice simple point. Let's pick x equal to 1, y and z to be 0. 1, 0, 0 is a point on the first plane, and we need a point q2 on the second plane. So q2, let's pick x equal to 4, 0, 0, 4, 0, 0. Nice and simple. Then the vector v goes from the point q1 to the point q2. So we take the components of q2 minus the components of q1. So v is the vector 4 minus 1, 0 minus 0, and 0 minus 0. So v is 3, 0, 0. And then we have to calculate the projection of v onto n, which is v dot n over n dot n times, that's a number, a scalar, times the vector n. So what is v dot n? Here's n up here, here's v over here. So v dot n is 3. It's 3 times 1 plus 0 times 2 plus 0 times -1. So it's 3. And n dot n, dot this with itself, it's 1 times 1 plus 2 times 2 plus -1 times -1. So that's 1 plus 4 plus 1, which is 6. So that's 1/2 times the vector 1, 2, -1. So that's our projection. And then the magnitude of the projection is the distance. The distance is the magnitude of this projection, which we'll just leave this as 1/2 here, and then the magnitude of this vector is the square root of the dot product with itself, which we said was 6. So it's the square root of 6 divided by 2. That's our distance.